Welcome. In this session, we start our study of integration. This is, in a sense, finding antiderivative. That is to say, if you tell me what the derivative is, I try to tell you what the original function is. This is much harder than differentiation. I will explain the reasons as we go along. The simplest way in which we can do this is to guess the answer, or at least try to guess the form of the answer based on our knowledge of differentiation. This works only for very simple examples. So let's start with one such. We will find an antiderivative of x cubed. I have a power function, so I think about what happens with power functions and differentiation. When I differentiate a power function, the exponent goes down by 1, which means that if the exponent is 3 after I differentiate, it should have been 1 more or before I differentiated. The answer must have something to do with x power 4. But the trouble is that the derivative of x power 4 is actually 4x cubed, but I want just x cubed. So I need to get rid of the 4 in the coefficient. So we can do this in several different ways, but only one can be moved in and out of differentiation. That is to divide by the coefficient. If I divide by 4, I get x cubed. And because 4 is a constant factor here, or equivalently 1/4 is a constant factor, multiplying by 1/4 after I differentiate is same as first multiplying by 1/4 and then differentiating. If I differentiate x power 4 over 4, I get 4x cubed over 4 because I'm differentiating 1/4 times x power 4. Derivative is the constant factor 1/4 times derivative of x power 4. That is 1/4 times 4x cubed or x cubed. So now we have an answer. X power 4 over 4 is a function whose derivative is x cubed. There are a lot of other answers to this problem. I can take x power 4 over 4 plus 2, for example, or x power 4 over 4 plus 5 over radical 2. In fact, I can take any constant, any number, so something without x in it, add it to x power 4 over 4. Derivative of a constant term is 0, so when I differentiate, that will go away. Means not just one answer to this kind of problem. But it turns out in some sense there is really just one answer. We can prove that two functions with the same derivative must differ by a constant. So even though there are a lot of answers to the question of finding a function whose derivative is x cubed, if I know one answer, I can tell you all the answers. I know one answer is x power 4 over 4, so any answer has the form x power 4 over 4 plus a constant. We represent all of them using the notation x power 4 over 4 plus c, where the understanding is that c is some constant. It's called the constant of integration. And this expression x power 4 over 4 plus c is called the general antiderivative. It is also called the indefinite integral. And we will see the reason for that when we talk about definite integrals in section 6 and 7. So this concludes our initial look at finding antiderivatives. We will talk about more systematic ways of doing this in the next several sessions, in section 2 through 5.